This footage captures a critical machinery entanglement where an operator's long-sleeved jacket was caught by a high-speed rotating lathe spindle. The resulting mechanical torque instantly overcame the individual's physical strength, drawing them into the equipment's path. This incident highlights a major failure in personal protective equipment P protocols, as loose clothing acts as a high-friction tether in industrial settings. It also underscores the danger of nip points and the lack of proper machine guarding, which should always enclose rotating shafts to prevent direct contact. Because industrial kinetic energy far exceeds human reaction time, self-rescue is impossible once snagged. Total compliance with safety zones and the use of physical barriers are essential to preventing such devastating workplace accidents. Complacency is the greatest hazard. Traffic incidents involving oversized loads result from a dangerous synergy between operator negligence and a lack of defensive awareness. Operators have a critical duty to mark protruding materials with high visibility flags or lights. Failing to do so creates hidden hazards. Meanwhile, motorists often fall victim to tunnel vision, focusing only on the road ahead rather than scanning for potential obstacles. This is compounded by the human reaction time of over 1 second, which, at high speeds, leaves no room for error. When drivers are startled by hazards at eye level, they may experience a freeze response rather than evasive action. To break this cycle, drivers must adopt a proactive mindset. Assume you are invisible to others and maintain a wide safety cushion. If you encounter an unmarked hazard, prioritize distance over frustration. Ultimately, safety is a deliberate choice, not luck. During a live testing session of a custom-built robotic prototype, an unforeseen incident occurred when the unit experienced a sudden loss of control. While the engineer made adjustments to the chassis, the mechanical arm unexpectedly executed a high-velocity, uncontrolled movement, striking a colleague seated nearby. This event highlights the inherent risks of interacting with robotic systems that lack comprehensive safety validation. The root cause likely stems from unrefined control systems prone to logic errors, which can command motors to move at maximum power, releasing dangerous kinetic energy. Furthermore, the incident underscores a severe violation of testing protocols regarding human proximity to active hardware. To prevent such hazards, it is mandatory to establish a clearly defined safety buffer zone and integrate a robust, accessible emergency stop system, as even engineers must never become complacent around their own machinery. From a safety engineering perspective, this incident highlights a critical convergence of systemic risk factors. Mechanical entrapment often stems from an interaction error, where infrastructure design proves incompatible with vehicle geometry, causing tires to lock within track flangeways. During such high-stress scenarios, decision latency exacerbated by loss aversion frequently leads operators to attempt equipment recovery instead of prioritizing immediate emergency egress. To mitigate these hazards, we must enforce a strict clearance buffer, ensuring sufficient space exists beyond the tracks before crossing. Preventive strategies, including infrastructure hardening with staggered barriers and automated radar-based monitoring, are essential to minimize human error. Ultimately, safety is rooted in proactive preparation. Always verify clearance before entry and, if a vehicle becomes immobilized, abandon it immediately. Personal safety must always take precedence over material assets in high-hazard zones.